Good day, everyone. Today, I'll be discussing gas laws, specifically Boyle's law and Charles' law. These laws help us understand how gases behave when pressure, volume, and temperature changes. What are gas laws? Gas laws are fundamental principles that describe how gases behave under different conditions of pressure, volume, and temperature. These laws help us understand and predict gas behavior in everyday life, from the air we breathe to the tires on our cars. There are four main gas laws. On Boyle's law, it focuses on pressure and volume. For Charles' law, it focuses on temperature and volume. For Gay-Lussac's law, it focuses on pressure and temperature. And for Avogadro's law, it focuses on volume and the amount of gas. In this lesson, we will only focus on the Boyle's law and Charles' law, the two most fundamental gas laws that form the foundation for understanding gas behavior. Gas particles move freely and spread out to fill their containers. Because of this movement, gases easily change their volume when pressure or temperature changes. This explains why gas laws works the way they do. In 1662, Boyle discovered that the pressure and volume of a gas have an inverse relationship when temperature is held constant. He states that at a constant temperature, the volume of a given mass of gas is inversely proportional to its pressure. So, if we squeeze a gas by increasing the pressure, the gas particles are forced closer together, making the volume smaller. If pressure is reduced, the gas expands and the volume becomes larger. Mathematically, Boyle's law starts with the volume being inversely proportional to pressure. This leads to the equation of pressure and volume equals to K, which is the constant. Different conditions of the same gas, we use the working formula P1V1 equals to P2V2. When using Boyle's law, temperature must remain constant, the amount of gas must not change, and pressure and volume units must be consistent. In this problem, a balloon has an initial volume of 2 liters at 3 atmospheres. When pressure is reduced to 0.5 atmospheres, without changing temperature, what is the new volume of the balloon? We use the formula P1V1 equals to P2V2 to solve for new volume. After substituting the values, we get the final volume of 12 liters. Since the pressure decreased, the volume increased, which makes sense based on Boyle's law. Now let's move on to Charles' law. In 1787, Charles discovered that the volume of a gas is directly proportional to its absolute temperature when pressure is held constant. He states that at constant pressure, the volume of a given mass of gas is directly proportional to its absolute temperature. When gas particles are heated, they move faster and spread farther apart, causing the gas to expand. When cooled, the particles move slower, causing the volume to decrease. The formula for Charles' law is T1 over V1 equals to V2 over T2. It is very important to remember that temperature must always be in Kelvin and not Celsius. In this example, a 600 ml sample of nitrogen is heated from 27 Celsius to 77 Celsius at a constant pressure. What is the volume of the gas? First, we need to convert it to Kelvin. Then apply the formula. After we solve it, the final volume is 700 milliliters. Since the temperature increases, the volume also increases, which follows Charles' law. And now if we apply it in real-life situations, Boyle's law can be seen in syringes, human breathing, scuba diving, while Charles' law is observed in hot air balloons, basketball on cold weathers, and car tire pressure changes on hot temperatures. Gas laws are all around us. Understanding them helps explains everyday phenomena and is crucial for engineering, medicine, and many scientific fields. For your evaluation, these practice problems help test our understanding of Boyle's law and Charles' law. For your instructions, solve these problems on paper, showing all steps. Remember to check your answers by verifying that your results make physical sense. And now to summarize it. Boyle's law shows an inverse relationship between pressure and volume, while Charles' law shows a direct relationship between volume and temperature. Both laws are used in everyday situations. And to remember, gas laws help us understand and predict how gases behave in science and everyday life. Master these concepts, and you'll see gas laws all around you. Thank you very much for listening.